Hello everyone, I am Ashwin R from MSRIT 8th and B section. My USN number is 1MS10CS144. The topic today I am presenting is artificial neural networks. Now let us consider what the problem is in our world. Our world is full of data. Data is generated humongously in day-to-day life, and our challenge is to understand, integrate, apply, and generate useful knowledge. The main key is to collect data that has been buried in data itself. System is usually programmed to perform a task, but instead of programming the system to do a certain task, we teach the system or the system learns how to perform a task. To do this, we need an artificial intelligence system. Neural networks is one such case where a system is able to learn from the data continuously. A neural network can be defined as a reasoning model that is based on human brain. Artificial neural networks can involve a bit of biological learning. The brain usually consists of interconnected nerve cells which basically perform the task of information processing. These units are called neurons. The thoughts always evolve from the neurons. Each neuron is a very simple structure, but a cluster of such neurons combined together bring us tremendous processing power. By the use of multiple neurons together simultaneously, the brain can perform faster than the fastest computers in today's world. So the brain has multiple neurons connected together which perform the given task or the thinking task. Neural networks can learn things that are actually taught instead of being programmed. That is, we teach a system how to do a basic task or the task that is given to the system instead of programming in the usual way. Now let us take a look at biological neural network or the basic nerve cell. Nerve cell usually consists of all these parts: dendrites, axon, synapse, and soma. Dendrites usually consist of nerve cells. I mean, they act as the connecting part between different neurons. And axon is the place where all the different uh, information flows. An artificial neural network consists of a very large number of simple processors which are also called as neurons, which are similar to biological neurons in the brain. The neurons in turn are connected to each other by weight links which pass signals from one neuron to another. Neurons outgoing connection helps in transmitting output signal. The outgoing connection in turn splits into a number of branches that transmit the same signal or different signals. The incoming connections of the neurons terminate the outgoing branches in the network. Now, let us take a look at artificial neural network architecture. It consists of three layers: input layer, middle layer, and output layer. The input signals pass through the input layer and are processed in the middle layer, and they are transmitted out through the output layer. Artificial neural network is a machine learning approach. That means it basically deals with machine learning and its process. The information about the learning task is given in the form of examples called training examples. Artificial neural networks can be specified as follows: neuron model, architecture, and learning algorithm. Neuron model. It gives the basic information processing unit of the neural network. Architecture. It consists of a set of neurons and links connecting neurons. Each link is assigned some weight. Now the last part, learning algorithm. It is used for training the neural network by modifying the weight. in order to model a particular learning task correctly on training examples. The aim is to obtain a neural network that is trained and it generalizes well. As we discussed earlier, the neuron is the basic information processing unit of neural networks. It consists of a set of links describing the neuron inputs with weights W1, W2, Wm, an adder function which is also called as a linear combiner for computing the weight sum of inputs as shown in the equation, and an activation function pi for limiting the amplitude of the neuron output. Here in this function y is equal to pi of u plus b denotes the bias. Now let us see the neuron diagram. Here the input values are x1, x2 and xn, and the weights are w1, w2 till xn, and sigma indicates the summing function, and as shown in the figure is the activation function from which we get the output. Now let us take a look at network architectures. There are three different classes of network architectures: single layer feed forward, multi-layer feed forward, and recurrent. The architecture of a neural network is linked with the learning algorithm used to train. There are many different types of learning algorithms which will be discussed later. Now let us take a look at single layer feed forward. In this there are input nodes and the output nodes, where there is an input layer of source nodes and output layer of source nodes. Multi-layer feed-forward neural network. Feed-forward neural network is a more general network architecture where there are hidden layers between input and output layers. Hidden nodes do not directly receive inputs nor send outputs to the external environment. Feed-forward neural network overcome the limitations of single-layer neural network. They can handle non-linearly separable learning tasks. As you see in the figure, input layer, these are the hidden layers and these are the output layers. Now finally, recurrent network. Feed-forward neural network is acyclic, where data passes from input to output nodes and not vice versa. Once feed-forward network is trained, its state is fixed and does not alter as new data is presented to it. It does not have memory, which is a disadvantage. Recurrent network can have connections that can go backward and forward from output to input nodes and input to output nodes, and models dynamic system. This is very similar to the recursive functions that are used in programming. Recurrent network is useful in solving problems where the solution does not depend on the current inputs but also on previous inputs. There are several applications of recurrent networks. Now two of them are used to predict stock market price and weather forecast. Now let us take a look at the diagram of recurrent network architecture. Recurrent network architecture with hidden neuron unit delay operator D is used to model a dynamic system as shown in the figure, where D is used to model a dynamic system which also acts as an input, and there are hidden layers in the middle and there are output layers which are indicated by the green circles. During the learning phase, a recurrent neural network feeds its input through the network, including feeding data back from the outputs to inputs. Process is repeated until the values of the output do not change. Recurrent networks can be trained by using backpropagation algorithm, which will be discussed later in this presentation. In this method, at each step, the activation of the output is compared with the desired activation, and errors are propagated back through the network using recursion. Once the training process is completed, the network becomes capable of performing a sequence of actions which are desired. Can a single neuron learn a task? In 1958, Frank Rosenblatt introduced a training algorithm that provided the first procedure for training a simple artificial neural network, which is also called a perceptron. A perceptron is the simplest form of neural network. It consists of a single neuron with adjustable synaptic weights and a hardened limit. There are several types of problems solved by artificial neural networks. Let us discuss some of the problems. Mathematical modeling, classification, clustering, forecasting, vector quantization, control, and optimization. Mathematical modeling. Modeling often mathematical relationship between two sets of data is unknown analytically. Data is often considered to be noisy. Classification. Assignment of objects to a specific class, that is, huge sets of data are classified accordingly to a specific class, given a database of objects and classes of those objects. Clustering. Grouping together objects similar to one another is known as clustering, which often creates a huge problem while grouping. Forecasting. Prediction of future events based on history. For example, usually the weather is predicted based on history and the future weather is predicted based on history. Trends and regularities often are marked by noise. Vector quantization. Object space divided into several connected regions. Objects classified based on proximity to regions. Closest region or node is declared the winner. Control. Manufacturing robotic industrial machines have complex relationships between input and output that requires a lot of control to be given to the user. Optimization. Requirement to improve a system performance or cost subject to constraints that can be improved by the use of artificial neural networks. There are several applications of artificial neural networks. Let us discuss some of them. Gotcha, biomedical signal processing, biometric identification, system reliability, business, target tracking. Gotcha, an effective application of neural networks. Current surveillance and reconnaissance systems structured to observe huge areas attempt to detect movement of hostile forces. Use of images to locate an explosion, run data back in time to identify the vehicle, lock onto the vehicle, and backtrack to locate significant portions of path, assembly areas, passenger pickups, arming sites, and any other spot with surveillance intelligence value. Biomedical signal processing and biometric identification. Instant physician are an is an application is developed by using neural networks. Network presented with a set of symptoms medical records are also used. Output is best diagnosis and treatment, which also acts as an efficient way to treat a patient. System control and reliability. Usually, there are several godowns and several factories that require backing up a truck to loading a dock and many other things which are not easy for an unexperienced driver. System control and reliability. Backing up a truck to loading a dock is difficult problem for a novice, easy for an experienced driver. Very difficult problem mathematically. Can train a neural network to efficiently load and unload a truck. Automobile airbags can undo serious damage to the passengers using the car. System reliability continuously assessed and failure prevented by correct interpretation of data from accelerometers. Business mortgage risk assessment reduces delinquency rates. Inputs include years of employment of dependents, property information, income, loan to value ratio, automated target tracking and recognition. Algorithms for automated tracking and recognition of targets have been recently identified by National Critical Technologies Panel as a critical importance to a mission of Department of Defense. Usually the missiles and the bombs that are used by Defense Ministry, I mean defense people, are automated to function efficiently. Automated target recognition, localization and tracking in the presence of artificial neural networks is an important signal processing problem. Practical application of artificial neural networks. Let us consider an example of customer loan approval where the real-time application of neural networks is given. Many stores are offering their customers the possibility of applying for a loan directly at the store, so they can proceed with the purchase of relatively expensive items without having to put the entire capital all at once. The loan applications are filled out at the store and the customer deals only with the store clerks for the entire process. The store, however, relies on financial company, often a bank, that handles such loans, evaluates the applications, provides the funds, and handles the credit recovery process when a client defaults on repayment schedule. Each application has 15 variables that included the number of members of the household with an income, the amount of loan requested, whether or not an applicant had a phone in his house. The 15 variables that include input and output variables are the number of relatives, and the value is from 0 to the number of relatives. Number of relatives with job, and the value is a numerical value. Telephone number, and then it's also numerical value. And the other input variables are real estate residency seniority, other loans, payment method, job type, job seniority, net monthly earnings of the family, collateral, loan type, amount of loan, amount of installment and duration of loan. Most of the variable values are numerical. Computed output variable, repayment probability from 0 to 100. Desired output variable, real result of grant loan, 0 if payment is irregular or null, 100 if payment is on schedule. Some of these variables were numerical. For example, the number of relatives. For each record, a single variable indicated whether the loan reached was extinguished without any problem, z is equal to 0, or with some problem, z is equal to 0. In analysis, the bank classified the loans with z is equal to 0 as bad loans. In the data provided or the data obtained from the net, only 6% of the loans were classified as bad from an example. Thus, ANN that classifies loans from a similar population ought to make errors in a percentage that is substantially lower than 6% to be of any use. Otherwise, it could have simply classified all the loans as good, resulting in an error of 6% of the cases. Out of 1000 available records, 400 were randomly selected as training set for configuration of ANN, which means artificial neural networks. The remaining 600 cases were then supplied to the configured artificial neural network so that it is computed output could be compared with the real value of the variable z. The, the research team selected a network with 10 hidden nodes as the one that provided the most promising performance. The number of iterations was set to 20,000 to allow sufficient degree of learning without the loss of performance in generalization capability. The single output of our network turned out to be in the range of -30 to +130, where the corresponding real output was limited to the values z is equal to 0 or z is equal to 100. A negative value of the output would indicate that it was a very bad loan. A 30% tolerance was used on the output so that the loan would be classified as good if the artificial neural networks computed a value of above 70, and bad if their output was less than 30. Loans that fell in the intermediate region of 30 to 70 were left as unclassified. This specific artificial neural network was then supplied with the remaining 600 cases of testing set. This set contained 38 cases that had been classified as bad, that is z is equal to 0, while the remaining 562 cases that had been repaid on schedule were classified as good. Clearly, the artificial neural network separates the given cases into two non-overlapping bands, the good ones near the top and the bad ones near the bottom. No loan was left unclassified, so in this case there would have been no cases requiring additional human intervention. By using this artificial neural networks, the allotment of loan could be made very easy depending on the repayment capacity of the individual. Now let us take a look at the diagram of the test case used. The probability of 70 to 90 includes a good loan area. The probability of 10 to 30 included a bad loan area. And the probability from 60 to 30 to 70 was defined as unclassified area. The dots in the good loan area are bold, which indicates that the probability that the number of people would repay the loan was more, and the diamond shaped squares in the bad loan area were less. That indicated that the people with the repayment capacity was less. Thank you for hearing me out for this presentation, and if you have any doubts, please mail me at winash77@gmail.com, winash77@gmail.com.